Okay, now after studying that specific energy, let's study about this specific energy curve, right? Now, what is this specific energy curve, right? So it is defined as the curve which shows, right? So the curve which shows the variation of specific energy with respect to depth of the flow, right? So this variation of that energy, right? So what is specific energy? So this is our specific energy, that is v square by 2g plus a. So variation of this energy with respect to the depth of the flow, right? So that curve is called as specific energy curve, right? Now how to obtain this curve? How is it, right? So now how to draw that curve? Let's study about that curve, right? Now it is obtained as, right? Now we know specific energy of flowing fluid is equal to how much? V square by 2g plus h. This is equation number 1, right? Now this v, right? So what is h? H is nothing but it is the potential energy of flow. That is nothing but ep, right? H is nothing but it is the depth of the flow, right? So this depth of the flow, it is taken as a potential energy, right? So therefore that is nothing but ep is equal to potential energy of a flow, which is equal to eh, right? And v square by 2g is nothing but our kinetic energy, which is denoted by ek. Ek is equal to how much? Kinetic energy of a flow, which is equal to v square by 2g, right? So this total, right, specific energy is nothing but it is the potential energy plus kinetic energy, right? V square by 2g, right? Now after that, now let's study about one term that is the important terminology, that is nothing but specific discharge, right? Now, so how to obtain that specific energy curve, we'll study later on this, right? So first of all, let's study about this specific discharge, because we need this specific discharge to draw the specific energy curve, right? Now, what is specific discharge? The discharge per unit width of the channel is called as specific discharge, right? So means what? Specific discharge is nothing but it is the discharge of that channel per unit width of that channel is called as specific discharge, and which is denoted by small q. So therefore small q is nothing but capital Q, that is our discharge through the channel, divided by b. B is nothing but width of the channel. So this is your specific discharge. So this type of question or this type of terminology in exam they may ask, right? What is specific discharge, or explain specific discharge. So this is your specific discharge, that is nothing but capital Q by small b, right? Now after this, right, now as we studied the equation number 1, this equation number is 1 is the specific energy, right? So what is equation number 1? That is nothing but specific energy, right? How much that energy is? So v square by 2g plus h. Now we have to obtain that specific energy curve. How to draw that curve, or what is that curve, right? Now, so this is equation number 1. As we know, what is the discharge, right? So discharge is nothing but a into v, area into, right, velocity. Therefore what is velocity from this equation? Q by a, right? So what is area? Q by, what is the velocity? Q by a, that is nothing but v is equal to Q by, area is nothing but b into h, right? Where Q is what? Discharge through that channel, b is the width of that channel, and h is the depth of the flow. So this product is nothing but area, right? So we can write that velocity of the flow, or mean velocity of flow, v is equal to Q by b into h, right? If you observe, what is this product Q by b? Just we have studied, that is nothing but specific discharge, right? Now what is specific discharge? Just here, specific discharge nothing but capital Q by b. So therefore, so this ratio Q by b is nothing but small q by h. So therefore velocity of flow is equal to, you can write Q by h. Now, so put this equation b by qh in equation number 1. That is equation number 1, right? So therefore the equation 1 will become, so that E is equal to how much? H plus Q square divided by, right, instead of that we put Q by H, that is nothing but V square. So therefore Q square by H square into 2G. This is equation number 2, right? Where H is nothing but your potential energy, and this Q square 2G into H square is your kinetic energy. That is your specific energy, right? Now after this, now this equation number 2, right? So this equation number 2 gives the variation of specific energy with the depth of the flow. If you observe, right, if you vary this H and the depth of the flow, So we'll get that specific energy variation from this equation number 2, right? Hence, right, hence a given a discharge, a give, hence for a given, hence a given discharge Q for a different values of depth of the flow, the corresponding values of E may be obtained. Means for different values of H, if you take different values S, and for a given discharge, that is Q, right? So we can obtain different values of E. Then after that we can plot their curve, right? Means we have to take different values. Suppose H is equal to 1, then find out E. Then H is equal to 2, find out E. H is equal to 3 meter, then find out E. Like that we will get the variation of that energy with respect to depth of the flow. So the curve, that specific energy curve, is nothing but what? It is the variation of that specific energy with respect to depth of that flow, right? Or this H, right? So that is our curve, right? Now after this, right, now the specific energy curve, or we have to plot that specific energy curve, right, for different values of EH, right? So the specific energy curve may be plotted by taking the specific energy on x-axis. Now take that specific energy on x-axis, and the depth, what the depth is nothing but H, take on this y-axis, right? Now for different values of this depth, find out the specific energy, right? So if you take different values of H, right, and different values of E, and if you plot the point, all that points, you will get the curve like this. This is your specific energy curve. This is your specific energy curve, which is having the equation is equal to what? E is equal to H plus Q square by 2G into EH square, right? So this is your specific energy curve for different values of depth of the flow. So you can obtain this curve by taking the different values of H, and we will get different values of E. And if you join all that points, different points, then you will get this curve, right? So you can find this specific energy curve in this manner, right? So we'll study about this H1, H2, Hc later on. What is this Hc, H1, H2, right? Now, so we can obtain this specific curve in this manner, right? Also, this curve is also obtained in another manner, that is nothing but what? Now we know what is specific energy. Specific energy is nothing but that H plus Q square by 2G into H square. So this is a potential energy, right? And this is your kinetic energy. So specific energy, right? So it can also be drawn, that specific energy curve, it can also be drawn by drawing these separate curves for the potential energy and for the what? This kinetic energy, right? Means what? Just read this. So just read this sentence. The specific energy curve may also be obtained. So you can obtain this specific curve in this manner also for different depth. So take different depths and find out the values of that E and plot this graph, and you will get the graph is like this. So this is your specific energy curve. Or in other way, you can draw that specific energy curve, right? How to draw the specific energy curve may also be obtained by first drawing a curve for potential energy, right? First of all, we have to draw the curve for this potential energy, right? How much it is? This EP is equal to EH, right? So that is your potential energy. How is it curve, right? So the potential energy, which is nothing but that curve is nothing but which will be a straight line passing through the origin, making an angle of 45 degree with the x-axis, right? So this is your potential energy curve, right?